Hi, this is Mrs. Bolin with your notes for 1.3. We're going to be solving some more equations today. So first of all, we will start with our warm-up and just go over what we learned yesterday. So remember, we always want to start by seeing where is that letter that we're trying to solve for. And then we get rid of any addition or subtraction first by doing the inverse operation. So the opposite of minus 8 would be plus 8 on both sides. So those cancel. Remember that whatever we do to one side, we have to do the other. So we have 3x is equal to 15. And then anytime a letter and a number are touching, it means multiplication. So the inverse operation on that would be division. So I'm going to divide by 3 on both sides. So I get x is equal to 5, and that is my final answer. Question number 2, I'm going to go through the same steps again. I'm going to subtract 12 on both sides. And then I have 7x is equal to negative 7. If you have a hard time with integers, adding positives and negatives, sometimes it's helpful to write out, this is 5 positives, so I wrote out 5 pluses, and then I have 12 negatives, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oops, I went into my next problem. So 5 of those cancel, so I have 7 negatives left over, and I'm going to divide by 7 on both sides, so x is equal to negative 1. So remember that you guys can pause me at any time if I'm going too fast, and then just get caught up in your workbook and then play the video again. Question number 3, the first step we are going to do would be distribute, then we're going to combine like terms. So we're going to go negative 4x minus 8 minus 12. There are other ways to do the problem too. You could have, for instance, added the 12 and then divided by negative 4. But if it makes it easier to just always do the same thing, distribute, combine like terms, add or subtract, multiply or divide last. Okay, so we're kind of working the problem backwards a little bit. So I'm going to combine the negative 8 and the negative 12. So I have negative 4x minus 20, because those are both negative. They make even more negatives. So I'm going to add the 20 to both sides. On this side, it cancels because my signs were opposite. So I have negative 4x is equal to 40. Then I'm going to divide by negative 4 on both sides. So x equals negative 10. Okay, question number 4. This is the one where you're like, I think I'll just skip it. No, but don't skip it. This one's actually pretty easy because this just means divide by 7. And so if I want to get rid of divide by 7, I just times by 7. So I do that on both sides. And so what's left is this, x minus 4. Here's where my equations balance. 3 times 7 is 21. So all I have to do after that is just add the 4. So x equals 25. Not too bad, right? So now we're going to be looking at equations with variables on both sides. So we are going to look at some of those problems together. The only thing I want you guys to be looking out for is that if the variable cancels on both sides, like let's say there was 4x on both sides and we minus the 4x and there's no more x's, if what remains is not true, like you got 5 equals 7, you would write no solution for something that's not true. If you get something that is true, like 5 equals 5, you would write infinitely many solutions if what remains is true. So is true. Sorry, that's on the next line there. Not ideal for highlighting your notes. All right, we're going to go ahead and try some problems together. So what we always want to do is distribute, simplify, do all that first, and then we want to get the letters together on the same side. And the way that we do that is by using the inverse operation. We're canceling out the same amount on both sides. Okay, this one doesn't have anything to simplify, but there's x's on this side and x's on that side. Okay, normally what I would suggest is take whatever number is less or smaller and move it over, do the opposite to cancel it off. However, this one, because there's a 10 on this side already, I'm going to move all the x's to the other side. So if I want to cancel out negative 4x, I need positive 4x. So on this side, the x's cancel. So I have 10 is equal to, if I have 9 negatives, 1, 2, 3, 4, 5, 6, 7, 8, 9 negatives and 4 positives, 4 of those will cancel and I'll still have 5 negatives left over. So I would have negative 5x. I'm going to now divide by the negative 5 because remember we're trying to find the value of that letter. So we want to see what's happening to it and do the opposite. So the opposite of times by 5 would be divide by -5. So I get x is equal to -2. Okay, problem number 2. Same thing. Okay, I already have some numbers over there, so I'm going to move my x's on over. So I'm going to cancel out those x's. So I'm going to go -3x on both sides. And then I have -5x is equal to 10. Then I'm going to divide by the -5. So I get x is equal to -2. Okay, question number 3. Before I can start this one, well, I could divide by the -3 technically, but I think I'm going to go ahead and distribute. So I have 15x plus 6 is equal to 15x. Okay, here's one of those times that I was warning you about. So what happens when we try to cancel out the x's from this side? So I'm going to go -15x, and I'm going to do the same thing on this side. Well, they cancel, right? So we get 6 is equal to, do you remember what we put if there's nothing left? If everything's canceled and it wasn't a division problem, if we're just adding and subtracting and everything cancels, we have nothing left. So we put a 0 to save the place. Well, does 6 equal 0? No, that is not true. So anytime we have something that is not true, when all of the x's have canceled out, we write no solution. There is no value of x that you can plug in there to make 6 equal 0. That will never be true. Okay, we're going to try this problem over here. Distribute the 4. So I have 4 minus 4p equals -4p plus 4. So again, I'm going to try to cancel out the p's on one side. So I'm going to go plus 4p. Well, it canceled out on both sides. That doesn't happen very often, but we just wanted to show it to you guys in this lesson so that you know what to do when it does happen. So on this side, I get 4 is equal to 4. And that is true. So my answer isn't 4. My answer is infinitely many solutions. Okay, all real numbers that I plug in here will make this true. All right. Maybe even imaginary numbers. It's a question for a different class. All right, question number 5. We are going to go ahead and solve that one. So I'm going to start by distributing. Then I'm going to combine some like terms. So I'm going to go 8 times 2 is 16r. 8 times 3 is 24. A positive times a negative is negative. And then we have that minus r. Then 3 times 3r is 9r. 3 times 2 is 6. So I'm going to look at this side first and combine some like terms. So I realize if I have 16 r's and I take one of them away, that means I have 15 r's equals 9r plus 6. Okay, now when there are letters and numbers on both sides, I recommend canceling out the letter that has a smaller coefficient. So for example, if I look at the r's, I have 15 of them over here and I only have 9 over there. So I'm going to go after the one that has fewer. So I'm going to go minus 9r to cancel those ones out. Well, I have to do the same thing on the other side. So if I have 15 r's and 9 r's and I pull away 9 from both sides, there's no more on this side over here. 15 r's take away 9r would be 6r. Take away 24 is equal to 6. Then I'm going to add the 24 on both sides. Now it's just a normal 2-step equation that we did yesterday. So then we have 6r is equal to 30. Divide by the 6. I'm running out of room. So r equals 5. Anytime you run out of room, your voice has to increase like this. All right, just kidding. Number 6, write and solve an equation to find the month when you would pay the same total amount for each internet service. Okay, well, company A is $30 plus you're going to pay $5.95 every single month. X is going to be however many months we have. Okay, then company B, I pay the installation fee of $12 once, but then I have to pay $8.95 every month. Okay, so make sure that we put an X next to those because those are repeating amounts. We have to pay those every single month. These ones don't have an X because we just pay it one time. Okay, so I'm going to subtract the smallest X, so 5.95 minus 5.95X. So I get 30 equals 12 plus 3x. It's kind of nice when we subtracted those decimals and the decimal part all went away. Okay, so then I just need to minus the 12, and I'm going to write my equation up here. So 30 take away 12 is 18 equals 3x, divide by 3. So x equals 6. Well, now we need to go back to the question because there's a word problem, right? So this says, find the month when you would pay the same total amount. So it would be after 6 months that we would pay the same amount for both companies. Before that, company B would be cheaper because it was only $12 to get started. Yeah. Okay, we're gonna go ahead and go over the homework assignment. Remember that you guys are entering this in Canvas and you are taking a picture of your work. Getting the answer is just as important as showing your work correctly. So make sure you write down all the steps, make sure you take a picture, and you submit your answers and your work in Canvas. I'm just going to go over just the odd problems, and then you guys are going to try the even ones on your own. And I think you should be able to figure them out, though, based on how I do the odd ones. So if you still have questions, email your teacher. Okay. So we're going to start with number 1. We're going to see that there's already a whole bunch of numbers over here. So I'm going to cancel out those x's so that all my x's will just be on one side. So I'm going to do the opposite of plus 3. So I'm going to go minus 3x. So I have 12 is equal to 3x. And then I'm going to divide by, how do you know whether you should divide by the 12 or the 3? Think about that. How do you know? You look for the x and see whatever's stuck to the x. Okay, since the 3 is stuck to the x, that's what I divide by. So x is equal to 4. Question number 2. Oh, just kidding, skipping it. Question number 3. So this one has k's on both sides. It also has numbers on both sides. So what I'm going to look for is the smallest value of x. So 3k is smaller than 8k, so I'm going to minus those ones. Subtract 3k. It's going to cancel on that side. So I have 45 is equal to 5k plus 25. And then I just say, well, now it's just a normal two-step problem. There's my k, but first I have to get rid of this plus 25. So I go minus 25 on both sides. So I get 20 equals 5k. And then in order to get the k by itself, I divide by 5 on both sides. So k is equal to 4. Okay, question number 4, we are going to skip. But just a heads up, anytime you have a fraction, you would multiply by this number and you would divide by this number. Okay, so when you're distributing it, so what I would use, I like to do the division first because it makes the number smaller. So if I go 48 divided by 4, well, that's 12. 12 times 3 is 36. 16 divided by 4, that's 4, and then times by 3 is 12. Okay, so I'll help you with that part because the fractions are a little bit confusing. You do the rest. Okay, question number 5. We are going to start by simplifying, combining like terms. Nothing to combine on this side, but over here I've got some q's going on. So I'm going to write 5q plus 6. Well, I've got 2 q's, 1 more q, that makes 3 q's. Take away 2. And then I'm going to subtract or cancel out the smaller number of q's. So I'm going to go minus 3q on both sides. Make sure that we are only putting q's with other q's. You have to keep the like terms lined up. So 5q take away 3q is 2q plus 6 is equal to negative 2. Minus 6 on both sides. So I have 2q is equal to negative 8. Divide by the 2 on both sides, so q is equal to negative 4. I'm going to skip question 6, but you would distribute and then cancel out the smaller value of s. Question number 7. Oh, great, googly moogly. These problems are super long. Okay, so make sure on this one we have a negative 8 that we're distributing. That's important. This one, same thing. I've got a negative 6 that I'm distributing. So I'm going to distribute first. I'm just going to copy the 3x. The negative 8 times 2x is negative 16x. Negative 8 times 3 is negative 24. Negative 6 times 2 is negative 12x. Negative 6 times 5 is negative 30. Then I'm going to combine like terms. So 3x take away 16x is negative 13x. Take away 24 is equal to negative 12x minus 30. Then I'm going to look for the smaller value of x. Even though 13 is bigger than 12, when it's a negative, that is a smaller number. So I'm going to go plus 13x. It doesn't really matter which one you choose. It's just a little bit easier if you keep everything positive. So negative 24 is equal to positive 1x. When it's just a 1, we don't have to write it. You can if you want to. It's not wrong. But it's the simplest way to write it would just be x. Then I'm going to add 30 on both sides. So I get x is equal to 6. Okay, we're going to skip question 8, but you would just distribute and then cancel out the smaller value of b from both sides and then solve your equation. On this one, it's another long problem. So we're going to distribute. We're going to combine like terms. So I have 16r take away 24 minus r is equal to 9r plus 6. And then 16r's take away 1r would be 15r minus 24 is equal to 9r plus 6. Then I'm going to go get rid of the smallest value of r. So 6r minus 24 is equal to positive 6 because those ones canceled. I'm going to add 24 to both sides. So I have 6r is equal to 30. Divide, but I'm going to run out of room here, you guys. Better scoot this up. So then I have r is equal to 5. Man, that was a long one. And then you guys can do number 10 on your own, easy peasy. Remember that if I can tell right here, 16f and 16f, whenever those are exactly the same, they're going to cancel. So then you just need to see what's left. If it's exactly the same, you write infinitely many solutions. If it's different, then you would write no solution. All right, and that is your notes for 1.3.